Okay, let's get started. So I want to start asking a couple of questions. How many people have the Apache Tory kernel working one way or another? That's half. Yeah. Hmm. So how many people have actually tried to install it and have failed? Does that mean the rest of you haven't tried at all? How many people haven't tried to install it at all yet? Okay, so there's a question about when you download Spark, do you need to also download Hadoop? No, when you download Spark, you want to pick the Spark that's pre-built with Hadoop. It's sort of weird, but it took me 5 minutes. I just downloaded it and ran. So any questions besides how to install Apache Tory? You have different questions about what? I have auto completion in my. Okay, that's a good question, and it's something you have to. By the end of the semester, I should be able to call you at 3 in the morning and wake you up and ask you the difference between a Spark context and a Spark session, right? And you should be able to answer it in your sleep. Right? What's that? No. So there's two things, right? When you run Spark, there's in theory there's three major data structures we can use to distribute things, right? RDDs, there's DataFrames, and then there is DataSets, right? And we need a point of contact to interact with Spark, so Spark knows how to distribute our code, right? And so there's a Spark context and a Spark session. The Spark context is used when we're dealing with RDDs, right? So we want to create an RDD directly, we use a Spark context. When we want to create a data set or a data frame from a file input, right? We need a Spark session. Now, a Spark session includes a data context, or a Spark context to deal with all the interactions with the cluster, right? But you have to start keeping these things separate. There's a Spark context and a Spark session. One goes with RDDs. When you read a file, you create an RDD. The other one we use to read files and read databases to create data frames and data sets.
So you said session?
Yes.
So a session.
The Spark session, if you have a Spark session and you want to create, there's different ways to create RDDs and different ways to create data frames. If you have an RDD, we can take that and create a data frame out of it. If we have a data frame, we can be able to downgrade it to an RDD. So when I talk about creating it, I mean, I'm going to read a file with some input and convert it natively into an RDD or a data set. If you've got a Spark session, you can always ask for its context, all right, and use that. Any other questions?
So, whenever I take out my code in Jupyter, it's like runs good a couple of times and then gives me errors. Is it for the class?
I get the same result every time. Yeah, you'll see some in a minute. Whoops, we going wrong way. One of the differences between RDDs and data sets is this whole idea of planning. So when you have a data set or a data frame, Spark goes through this whole process of planning. So it takes your user code, it basically converts it into an abstract syntax tree, creates a logical plan, what they call a unresolved logical plan. The catalog is just basically the schemas that you have around in all your data sets and data frames. And then the analyzer then figures out, do you have all the rows and columns you say you're going to use? And the resolved logical plan just says, look, yes, when they said they're going to do select a column called foo, there's actually a column foo in that data frame. And then the optimizer basically figures out what's the best way to execute that code to be very efficient. This happens with data sets and data frames. It does not happen with RDDs. Another thing that data sets and data frames have that RDDs don't are schemas, right? So I created this little file with, JSON format with, some names, and then, I'm using, again, the convention is that SC will stand for Spark context, and Spark will stand for Spark session. And so I'm using a Spark session. Why? Because I want to get a data frame from the file. And so I want to read, get the format of the file, and then I can load and give it the file name. And when I look at it, I get a table, right? And so what's happening in JSON, when I read JSON, it's using the keys as a name of the columns, and it's guessing in the types. So when we load the file, then ask for the schema, we get the schema, and it's basically a struct type, which means there's a compound type. It has multiple columns, and then it gives you each field for each column, and it gives you the name and the data type in Spark, and it gives you the third argument is whether or not it's mutable, it's nullable or not. Can the value be null? Right. So we have schema. And again, this is something we don't get when you do RDDs, you don't need. But when you read in a data frame or data set, there has to be a schema, because that's the one thing that makes it different between an RDD, right? And so when you read in JSON, it's going to try and guess what the schema is. Now we can specify what the schema is. We want the schema to be. So here I import the fields, types, and string types, and then I can create a new struct type and build in all the values I want, various data types. And then when I read in that file, I can specify that's the schema to use. Right, so I'm specifying first and last are string types, and here I'm age is integer type. Instead of making it a long, it's going to make it an integer. So we can specify our own schemas. So far, so good. No complaints. When I specify a schema, in this case, I didn't put the age column, I put an address in. So I told it to use that schema, and it reads that data. It says, well, you said you didn't want age, so I'm not going to read it. And you said you wanted an address, and I couldn't find it, so I just create them all null.
False.
Yeah, so wasn't that interesting? Yeah. But what else can it do?
So
Yeah, the question is what happens when, I did that on purpose, set it false and say, oh, what, I would expect it to throw some sort of error, and it didn't. Now, I didn't check to see if this is, when you're in the notebook, it does some things slightly different. For example, when you declare a val, you can redeclare it. And it doesn't complain, like it doesn't say, sorry, but you already declared it. I didn't check that. My guess is it's just going to make them all null. And these nulls are something we'll talk about later in terms of when you start getting real data. The problem with real data is that it's always messy. There's always mistakes. There's always things missing. There's always problems. And then we have to figure out what to do with it. So it turns out, when we have comma separated files, we do the same thing. Although the more work, we have to tell it whether or not there's a header or not in the comma separated file. Because if there's a header, then we'll use that as names of the columns. If there's not, then we won't. We have to tell it to infer schema. And then you need to tell it what separates the various columns in your data. In this case, it's tab separated, so it's the tab and not the \t. The \t, it looks for a \t instead of a tab. And the interesting thing is that when you read in, it's smart enough to look at to analyze the types and recognize it as a timestamp, and actually convert it into a timestamp object instead of converting into a string. Right, so in reading data into a data frame, we have to work with the schemas, and we can create our own schemas to tell how to read that particular data, given JSON format and CVS with headers. Spark will infer it for us. In either case, we can specify our own schema to use. So far, so good. Like, what does that have to do with the assignment? It doesn't have to do with the assignment. Why are we talking about it? So let's look at some transformation and actions, first in RDDs, and then we'll look at dealing with data frames. So here is, a simple program. All these examples I ran in the Jupyter Notebook. So this should run, and it should always give you the same answer. So it's a pretty simple program. What are we doing? Well, again, it's SC for context. Instead of reading data, I'm going to parallelize a list. And that will create an RDD, which will be executed on the worker nodes. And map is a transformation. So it's not going to be executed on the master node. It's going to be executed on the worker nodes, right? And all I'm doing is I'm adding 1 to all the values. That's interesting. And then when I call collect is a action, and the action then takes the results that are on all the worker nodes and brings them back to the master node, and collect just gathers all the data, and collect returns it not as a RDD but as a local data structure. When we're in Spark, it returns an array. So it starts to become important to understand when we're dealing with RDDs, which are located on the worker nodes, and when we're dealing with data, it's on the master node, right? And the map is pretty much the map you expect in Scala. You give it a function, right, with 1 argument, and then it returns the value, and that transforms the set. But in this case, that map is not being executed on the master, it's being executed on the worker nodes. And then there's things like distinct, which is, give me all the distinct values, but again, it's done locally on the worker nodes. And then when I call collect, it's going to collect it. And of course, here the work is a little interesting, because what happens if I have two repeat values? What if one's on one worker node and the other is on the other worker node? When they do the distinct, how they're going to know? It's one of the things we don't have to worry about too much. And then there's a sample we can call to tell it, give me a sample. The first argument is, do you want replacement or not of the sample? And the second is the percent of the data you want, so here I'm getting, give me half of the values. Right, so just some simple, well, in this case, yeah, it depends. First of all, 0.5 is not half, right? It's a floating point number. So it's going to be, when you're dealing with, 500 gigabytes of data, half is half, right? I mean, if you're off by 50 or 100, who cares, right? When I did it here, sometimes I got one, sometimes I got two values. Yeah, and it's not exactly, you have to keep in mind, right? You have a bunch of worker nodes and the data is distributed, and now you're going to say, give me half. Does that mean half of each on each node? Well, but this, again, if I got four values and I got three worker nodes, one of them have two and the other going to have one, right? So what does half mean? So it's approximate. Various transformations on two data frames or RDDs. So I create two lists. I can do a union, right? Combine them together. I can do intersections. I can subtract one from the other. Right? The results aren't surprising. That's what we expect from unions and intersections. So here, how do you get your output? So Spark has a number of ways of writing RDDs and data frames to the file. So, I parallelize them to two RDDs, to the union, and now this result, right, remember, is now another RDD, right? And it's not computed until we want the results, right? And now when I call results, right, save as a text file, you have to remember now what's happening is that this is being executed on, you have all the various worker nodes, right? So when I save a text file, what's happening is I'm going to get on the files are saved on the master node, not the worker nodes. So it's really an action here, right? But for every partition we have, right, we get a separate file, right? So I was playing around with a number of different partitions. So I had 7 partitions. So the output of that union is spread across 7 files. Now, normally you have like 1 partition per worker node. Since I was playing with that, I only had 2 cores at the time, but what happens when I do a partition of 7, and it gives you 7 different threads to work with. But most of them, the repeat, 1 core is handling more than 1 partition. Okay. Now, once you bring the data to the master node, right, with something like, say, collect, that is on the master node. And now you're dealing with a Scala data type. And if you want to save it to a file, then you're dealing with a normal Scala code, right? You're not dealing with Spark anymore. So it's very common, right, to do a bunch of work on all your nodes, and then you save as files, right, rather than trying to bring all the data back to the master node and then save it. What's that? Yeah, yeah, but then how do you save an array, right? I mean, you could write it to a file, right? But it's going to take you more code than that, right? Yeah, these are text files. The underscore success is a 0-byte file. There's no content. It's just tell you where things failed or ran successfully. And these are pure text files, yeah. You know, a bunch more actions, right? Collect, reduce, first, top, take, ordered, take ordered, count. Count by value gives you a map of how many times each value occurs, right? So 3 occurs twice. So you see 1 occurs once, 2 occurs once, and 3 occurs twice. And that is surprisingly more useful than you think. And then there's a bunch of, you take means and mins and max and standard deviation and all that sort of stuff. Right, and the stats one gives you, a bunch of different, the count and the mean, standard deviation, the max and min. Histogram takes a little interpretation. You give it how many buckets you want that data to be divided into. And the first array gives you the boundary points. So the first bucket goes from 1 up to 2.33, and the next bucket goes from 2.33 to 3, and the next bucket goes from that all the way to 5. And then the second array tells you how many elements are in each of those buckets. And so if you were to have done an assignment, your previous assignment on Spark, right, and you computed all those samples, looked at their means, and then did a histogram of the means, you would see that, of those means, the far out were very few, and there's more and more of them, right? So the inner buckets would contain more elements. Working on RDDs of pairs is also common. So here I create 2 RDDs and I zip them together, right? So it's basically, you can think of it as RDDs with 2 columns, right? Or tuples. And here I do reduce by key. So what's happening is, this is a very common operation. And so it says, look, what I want you to do is do the reduce key by key. right? So do reduce on 1, and then do the reduce on 3. And you notice that for 1, we get a sum of 6, which, is 2 plus 4, right?
Value. The top of 1, 5.
Yeah, so all we're doing is we're taking all the tuples of the same key, right? And then sending them to reduce. So I get all the tuples that start with 1, and sometimes it's adding, I'm going to get that sum. Group by key is somewhat similar. It gives me all the values that have key 1, all the values that have key 3, and then there's some internal representation, which is this compact buffer to store them somehow. Map values allows me to increment the values or do some map on the values. And then I can, give me the keys, give me the values, various operations. So far, so good. Okay, now it's time to wake up. This slide is very important. You want to pay close attention to this slide. It's very subtle, and if you don't understand it, you'll waste many, many hours. Okay, so again, I parallelize this list, right? And so now I have an RDD, and I just want to sum them all up. And then there's a for each, which iterates through all the elements, right? And so what I do is I have my sum, and then I just add the values of sum, and then I look at the value of sum, and the value of sum is 0. Huh? What did I do wrong? Maybe my kernel is wrong. Maybe I'll spend another couple hours trying to debug my kernel because there's clearly something wrong. Because when I add 1, 2 up to 6, I don't get 0. I get anything but 0, right? But that's not what's going on.
You have to assign.
Assign what? No, it doesn't return. A doesn't return it, or it doesn't return a value. What's that?
It's got to be the argument.
And what are the arguments for the for each loop? If you were to do this in Scala, it would work right? And where are you looping over them? They're on remote machines. Oh, right. And where is that sum? It's on the master, right? And so what's happening here is when you execute on the local machines get a copy of the environment that for which is executed in, so it gets a copy of sum. So each worker node gets a sum. It adds their part of the list to the sum, but They're on local machines, right? And it's a local variable which you have no way of accessing, period, right? Absolutely no way. And then you say print out the sum that's on the master machine. Well, no one changed it because the worker nodes have their own separate copy, right? Their own separate copy. No, sum.collects, no. The sum, you want that sum argument, right? That's a local variable in this program, right? It's a local argument, a local variable in that program. And if you've got 4 worker nodes, you've got 5 separate copies of that program, right? Completely independent. And the only way you've got to communicate between those 4 and the master are through RDDs or data frames. Or you could write the results to a file on each local machine and then log on to each machine and read the results, right? What's going on here is they've abstracted out the idea, all that work you normally would do to distribute all the code and distribute the data and then return results, right? So it looks like you're running a simple program, but the program is being run. There's a master which controls everything, but every time you call a transformation, it is being done on the worker machines, not the master machine. And so you really want to be careful about where is all the data, right? That sum is on the master machine. Oh, A is an RDD, which means it's not on the master. It's on all the worker machines. Different location, right? Hopefully you start to seeing why this is important, right? Because you, when you write Spark programs, you're doing it so they can use multiple machines. And RDDs and data sets and data frames, they exist on the worker machines, and they don't exist on the master. Any local variables you create in your driver program will exist on the master and on the local machines, on the remote machines, but they're different copies, and they're not synced back up. Now, if we call reduce, that works for 2 reasons, right? One is I'm not using sum. I'm just saying A and B. Those are arguments to the function that reduce is using. So I'm not accessing global data. Secondly, reduce, right? It's an action. So it's going to call reduce on all the worker nodes, and then it's going to grab results from the worker nodes and bring them back to the master node, and then apply reduce on it on the master node and produce 21. Is it an action or a transformation? Is it? I think it's a transformation. I'll look it up, but even if it is, I mean, how can it be an action? Because then it's going to have to return different results, right? So the lesson here is several-fold. One is when you're writing Spark programs, right, you're not, it looks like a simple, it's a 4-line program, but there's a lot going on, and not all of it's been done on the one machine, right? It's been done on the worker nodes, and actions will bring results back to the master. Any questions? Why would I reduce? So the question is, why do we want to use map and reduce rather than for loops? Yes, a good example why, because map and reduce, we think of it as a simple function that's being executed, right? But it's, in this case, this distributed computation has to send, right, that lambda to all the various machines, right, and do the execution and bring it back. To do that in a for loop is extremely hard. People have been working on how to parallelize an arbitrary program with for loops. They've been doing it for like 40 years, right? It's a very, very hard problem. Very, very smart people have been working for decades on it, and they have limited success, right? And literally, I would say it's within your grasp to implement a reduce function which did this, right? This semester. Any other questions? So don't forget this slide, right? This is so let's look at data frames and data sets. We can add rows and columns, we can move columns, we can change rows and columns, we can change order columns, we can modify columns, we can't modify, we can add new columns, we can't, because data frames and data sets RDDs are immutable. But now I've got a question for you. If you're going to go to Spark API documentation and look for the methods that you can call on a data frame, where would you look? What's that? You're running 211? 2 point. And has anyone tried that? No one's tried? For what? Data frame? And 2.2? Can anyone else with all these computers find data frames in the 2.2 documentation for Spark? You can find it in 2.1. Yes, it's not in 2.2. Can anyone find it in 2.2? Data frame. No. I'm looking at the API documentation. If you want to look at the DataFrame class and find all the methods that exist in it. And what does that mean? Yeah, so we talk about there being these three major data structures in Spark, right? RDDs, DataFrames, and DataSets. And if you go to the API documentation, you can look up RDD class and see all the methods, right? And you go to the DataSet class and you look at all the methods you can execute in that. But when you start looking for the data frames, you're not going to find a data frame class. So you can look at all the methods. And the reason is that a data frame is just a data set, right? The data set, right, has a schema, and you specify the, the schema by creating a class enum in Scala, right, which specifies the name of each column and the name and the type of each column in code, right? So a data frame is just a data set whose rows are of type row, as opposed to whatever your type of class you use. So in essence, you can just think as a data frame as a instance of a data set. So all the operations you can perform on a data frame are exactly the same operation you can perform on a data set. Now there's probably a generational thing going on here, because when I want to know what operations I can do to get things done, I'm used to going to the class definition and look at it, like, tell me what you got, so I can know what a lot of programmers these days, when they want to find out what they can do, they go to Stack Overflow and say, how do I do X, right? The problem is you're assuming that someone on Stack Overflow has answered your question in advance, and usually they're answering a very narrow question, right? It's like, well, I'm trying to solve this problem. What are my options? And if you go to the class, you can see what your options are, right? So yes, if you want to know what you can do in a data frame, go to the DataSet class, and the operations listed there are the ones that you can do on a data frame. So I'm going to do a bunch of examples again. I copied most examples from this text, the data from this book. And again, it's the data set containing the number of flights, scheduled flights from one country to the other country, with one of those countries being the United States. And it's origin country name, then destination country name, and then the number of scheduled flights, right? Now, I don't know if that's per week or per day or per month or per year. I don't know. I would think there's more than one flight per year going from Croatia to the United States. And then I read it in JSON, and just to give us some data to, right? And most of the operations we now do on data frames and data sets are like SQL, right? The operation to an RDDs are just basically pure scalar functions like this map and reduce and collect, right? But here, most of the operations are going to look very similar to what you can do in SQL. And actually, almost every operation you can do in SQL, we can do it in code and vice versa, right? So common ones, how do I select something from a table, right? And so in Scala, there's a select statement. And what the select statement does in Spark is the same thing it does in SQL, right? It's selecting which columns you want from that data frame. Right, so just give me those two columns, and that's what I get, right? Now here I didn't need to import the expressions call or column yet because I'm in my select statement I'm giving just pure string. If your select statement just has strings, right, it's going to interpret those strings as the name of columns, right? So already it's sort of weird because now it's become, you're given arguments, but those arguments are column types, the columns. There's a bunch of different syntax we can use. I can just say column and then name of the column. I can do the abbreviation. In Scala, there's a shortcut where I can use a tick mark. That interprets that as the name of the column. There's also the $ quote mark. And we can also do expression. A column is one type of an expression. We can also then give the name of the data frame and then which column we want. That will allow us to select columns from different data frames if we want. Now notice one thing. I did not also give you an example of calling the straight string. Why? Because as soon as you do that, it does not work. You get this compiler saying, I can't figure out what you're trying to do here. Because if it's just strings, it's smart enough to realize those things are going to be converted into column types. As soon as one of them is a column type or an expression type, the compiler gets confused and says, I'm sorry, I can't deal with this. And I also found a couple of places where the tick mark or the $ double quotes mark also didn't work. Why? I don't know. Thought I caught that typo. We can do all kinds of operations in columns. So here I'm adding to a column. I can do it column, some column name, in parentheses, and I subtract. Or I can do it inside the string, right? So it's very weird. Inside the expression or column, we're doing some weird things. So this column, double quote, column name -5, that we can explain because we can define minus and plus, etc. on a column type to do the right thing. If you do it the reverse, you say 5 plus column, you get a compile error because minus is not defined on integers or base types that deal with columns. The expression here is basically telling us that Spark is going to read that string, and it's going to then parse it, right? Which means we're getting runtime checking of that expression, right? But we can do various operations like this, so we can start doing various computations on data sets, data frames. So here's an example. It's a nonsensical example, but so I'm going to do a select on the data frame with all our flight data, and I'm going to. The reason I did call instead of having the strings because I need the call to do an operation on it. So all of a sudden I can't just pass in a string. So it's call, and then it's column up 1 by 2 minus sign, and then again it's this weird thing that's going on, right? Because now argument to sign is a column name, right? And what this means is, right, for each row in that column, perform this operation, right, and then create a new column with the result. If you just look at it, it seems reasonable. As soon as you start thinking about it, it's like, what? Right? Because what this select does, it says, okay, select these columns, but as soon as you start doing computation, it means we're going to go row by row through the original data frame and apply this computation and create a new column with that result. We're doing it row by row, in this case on the count column. Now, if I had another numerical column in the original data set, right, I could have, say I had count and, I don't know, cost, right? I could have times 2 minus sign of cost, right? Or I could have taken count times cost, right, to figure out how much revenue has been generated by that flight. If you think of count as a variable, it makes sense, yes. Basically count stands for that column, right? And we're going to apply that. And that, we think of the variable, it's going to go through all the rows in that column and apply that operation. If you think about it as an SQL statement, it makes a little more sense, right? Because in SQL, what do? You say select this column and then again perform operations on that column, right, and get the result back. But all of a sudden, this is not acting like a normal higher order function, right? That can map and reduce to on scalar data types or RDDs. So far, so good. Supposed to be expression, not expo. Why am I need O instead of R? So this allows us to do several things. I can now take that expression that I did with columns and put it inside a single string, right? So again, it's expression and then what I want to do, right? And I can then also give that column an alias so it doesn't use the computation itself, right? So I can give it a more reasonable name rather than what the computation does. So far, so good. Select expression is a shortcut for doing select and then applying expression to all the arguments inside. So now I can, instead of having to do expression, I can just say select expression, and then I give it, as I did before, I give it the two column names, and then the one operation, but then I also can now rename it inside that string. When I do select expression, the star means select all the columns in the existing data frame. And so I'm just adding a new column to what already exists. And here notice that my second expression is referencing two different columns. And so what I'm asking for is when are the two columns have the same value, right? So far, so good. What they call aggregate functions, trying to compute, some summaries of the data. So count is one. So the first column, I'm taking a sum of count. So it's just basically taking all those numbers in that column and adding them up and producing a single value. Count destination country names is basically just counting how many elements are in that column, which is basically the same thing as the number of rows we have. Distinct, on that column says, give me all the distinct values in that column, and then I can count those. And then I do the same thing with it says that there's 257. Oh no, you forgot one thing. In country. Yeah, apparently, I mean, but we can now start doing summary data, right? Well, here, first of all, these aren't normal high order functions, right? Because these aren't, I mean, they're just strings. So they're being applied, you know, Spark is parsing these strings out and converting them into functions for us. And they're being applied on each row, right? And typically, yeah, I mean, it's like SQL, right? You expect there to be a lot more rows and columns. But if you've got more rows and columns, you don't have much data, right? Any other questions? Let's see. Yeah, so how do you find out which functions you can use, right? If we're looking at operations we can do directly on an RDD or a DataSet or DataFrame, we can go to the API documentation, right, and look, and there is an RDD class, and it gives you all the functions that we can operate on. These things are embedded in strings, right? So how do we know which operations we can actually use as opposed to, and the answer is, most of them you'll find in the org Apache Spark SQL.functions, which is just a list of all the functions you can use. There's some extra ones. There's DataFrame stat functions, which start doing some statistical computations. And then there's a DataFrame NA functions. Those are used for data cleaning. What happens when you get nulls? How do you deal with the nulls? Um, personally, I find these languages embedded in strings a little frustrating because, like, how do I know what I can do in there, right? Um, when you're dealing with pure Scala or pure Java, you can look at the classes and see what operations they allow. Scala gets more complicated because you can do these funny magical things over there, which affects things over here. But at least you can have some hope of looking for what's embedded in a string. It's like, well, there's some parser embedded in Spark, which is parsing that string. Where's the documentation? And this is where you find. Um, any questions? Well, there's one question people ask me occasionally, and I haven't answered, and I keep on forgetting about it when I come to class. The question is, when will we have an exam? And since people are asking, I picked a date. And I used to say I give you an option of 3 dates, and I would say in my entire teaching career, whenever I gave students a selection of 3 dates, they always picked the last one. Always. In 30 years of teaching, I have not come across an example where they picked so like, there is more material, you're right. But unfortunately, I haven't come across a class yet in 30 years where your opinion was the majority. So there's no reason for giving you an option because you can pick the latest one. So November 2nd, which is a Thursday. It'll be a couple weeks.
Kind of a side question. So you start like more context, stop it. Is there a way to background?
That's it. How are you running the program?
So sometimes and then after
So if you're in the Jupyter Notebook, there is a tab called Running, and it'll show you all the running processes. And when you look at that, it gives you an option of killing them. So it depends on how you're running. If you're running it as a regular program with SBT or do IntelliJ, when you run it, when it stops, it'll stop executing. When you're on a cluster, the story is different.
yeah, I'll check it out.
Yeah. Also, you can always just kill all the kernels, right? Go and stop notebook and restart it. That will. Well, just kill Jupyter Notebook, right? When you start up in terminal, you get the session, you go there and you kill it, and okay, we're done for today.